Okay, so this time we're going to have a look at a non-parametric test. And for this example, we're going to have a look at parity. Parity is the number of previous births a mother has had. I think it's births. It could be pregnancies. Someone correct me if I'm wrong. I think it's the number of previous births. And we'll see there's some different patterns in the data here which might lend itself more to a non-parametric test. So I'm not going to bring up those assumptions again, but we would start off by following the flowchart, choosing an appropriate test, and we might use as a starting point, can we use an independent t-test, check the assumptions, and if they're not met, use to a non-parametric test. Unless you already know from the outset that you definitely want to compare the medians, we would usually try using an independent t-test first, just because it's a bit of a stronger test and you're more likely to get a result. But if you've got a very small sample size, or you know you want to compare the medians, then you wouldn't use a t-test. So our outcome in this case is it's count, because we're counting the number of previous babies a mother has had, but it's continuous enough that we can use it in this sense. We still have our two groups, and then the third assumption is that we have independence of observations, and we're going to assume that's okay. And so now we're going to go straight to looking at the outliers. So hopefully you're feeling confident now that you can do a box plot. This time we're interested in parity. I should add here, there's no reason that the parity should be different between the two groups, and whether or not we would actually care. I guess if the parity was different, and I don't know if parity is linked to birth weight at all, then we might care. I'm not doing this for the purposes of finding out if there's a difference in parity. It's more just as an example, in case you're feeling offended that I'm looking at the difference in parity between smokers and non-smokers. Okay, so I've dragged in the ever smoke to the x-axis again. So here we can see a difference in the outliers in that they're very much all on one side. So this is indicating that our data is going to be really heavily skewed. And we would expect this for a variable like parity, where you've got a good proportion of the women will be first-time mothers, so there'll be a lot of zeros, and then the rest have probably had like one or two, and then we might get a few who've had larger families. And some of these are very large families, by the way, but that's why I think this might be slightly older data and not Australian data. So we do have some outliers which are of concern. So you might even stop there and decide to use a non-parametric test. I'm just going to quickly do the histogram because I can, really, I suppose. May as well. Here we can see that it's very much not normal. In fact, it looks like half a normal distribution. It looks like we had a normal distribution and we chopped it in half, but we can't have negative parity, so there's no way it could go back down the other side. So we've got a very skewed distribution. It might be a good idea to test the median number of previous babies rather than the mean. And so we will use a non-parametric test where we're not making any assumptions about the distribution. Now these are actually easier to do in SPSS than the parametric ones. All you have to know is that you're looking for a non-parametric test, and whether you've got one sample, independent samples, or related samples. We've got independent samples. You don't have to know the specific name of the test, it will choose it for you. And there's two things that we might want to do, and I encourage you to go and read that Laird page on the Mann-Whitney U if you haven't already, because it gives a really good description of it. Basically, we're not assuming that the data is normal anymore, so there's two things that we might want to test. Is the shape the same? And is the median the same? Now, if the shape is the same, then the test, if you run it again, will compare the medians. There's a small technicality where if the distributions are not the same and then you tick this box, it actually means the mean, you're testing the mean ranks. But unless you're super interested, I'm not concerned if you're not too sure of the details on that one at this stage. So we're going to compare the shape of the distributions. We've got parity and ever smoked, and click run. And here it gives us the null hypothesis that parity is the same. It tells us which test it's doing. We've got a really high p-value, and it says retain the null hypothesis. So we've got no evidence that there is any difference in parity between these two groups. It will give you a little bit more output if you double click into this box. In this case, there's not anything very interesting there, simply because there was no difference. So there's no difference in the distribution or the shape, which actually we can see from here, they both have a very similar shape. So now we might test the median. Is the middle the same? Independent samples. I'm going to go back to objective up the top here. And now I want to compare the median or the center of the distribution. The medians of parity are the same as the null hypothesis. It's doing a slightly different test, it says. People, you'll find, normally report this as the Mann-Whitney U, and you can look up more details if you're curious. The significance is very, very high, and so we've got absolutely no evidence to believe that there's any difference in the median number of previous babies for the two groups. And it says the grand median is 1, so the middle value for previous number of births is 1 for both the groups. And even though they look a little bit different in the box plot, this is telling us that it's not statistically significant. Okay, so in that case, I probably wouldn't do any further graphs, simply because there is no difference to look at. If I was going to do a graph, I would not do the error bar chart, because that shows the mean and I haven't tested the mean. So I might simply use the graph that they've done here with the box plot, or perhaps I would use the graph, one of these ones I'd used before, and I might put the median on it, and we can see how to put lines on graphs in a separate video.